Hello everyone. Today we are going to start a virtual segment in Bidwan class. So I am a faculty member of Bidwan class. So here we are going to start a topic on a physics, that is optics topic. From that we are going to start here refraction and its refractive index. Okay. So what is refraction? Already we have studied there in previous classes, and today we are going to start the refraction. So refraction means that is the bending of light, and why it occurs and how it occurs, now we are going to see. Clear? So first we'll see what is refraction. So let me tell you that refraction means the bending of light, and this bending of light occurs only in one condition, when the ray of light is going to pass through an obstacle which is having the wavelength nearly same as to that of the wavelength of light. Okay, so refraction means the bending of light, and the cause of the bending of light is the change in the speed of light. Change in speed of light. Okay, this is the cause because of which we are getting change in speed of light. So why the speed of light changes? This question arises, isn't it? So the change in speed of light is occurring because of a main reason, that is the optical density. So till now we have heard about a word, mass density. So mass density means mass per volume, but optical density means what? That is totally different from mass density, is not similar to that. So optical density means the density of the medium in which the light can travel. Okay, so whether the light can travel freely with a very faster speed, or whether it can travel with slower speed. So accordingly that density defines the speed of light. Okay, so the speed of light changes because of this optical density. So now we'll see what is optical density and how we can measure. So this refraction index is the parameter which measures the optical density. So already we have studied that mass density can be measured by the mass per volume, but optical density, to measure that we can use refractive index. Clear? So refractive index means it is the index of refraction, or which measures the bending of ray of light when it passes from one medium to another medium. So when it is passing from one medium to another medium, always it bends. So first we see that how it is bending, then we'll go for the refractive index. So here a picture is there how it is bending. So we'll take for different condition. So if a medium is there or an interface is there which is dividing the two medium, the first medium is from which the ray of light is traveling to the second medium. So if the first medium is rarer medium, so according to the optical density of the medium, we can say whether the medium is rarer or whether the medium is denser. Clear? So rarer means if its optical density is less, that means the light can travel easily through the medium, then that is called as the rarer medium. That means air particles inside that medium is very far from each other, so light can travel very easily or with a very faster speed. And in denser medium, the air particles are very close to each other, that's why the light has to travel with some not ease, so that's why the speed of light will be less there. Clear? So here to understand the refraction, so we'll consider an interface, and this is the normal to the interface. And now one incident ray, if it is obliquely incident on the interface, then what is the angle between the incident ray, this is the incident ray, and the normal to the interface, that is called as the angle of incidence I. And if there will be no obstacle or no intermediate medium will be there, or interface would be there, then the light should travel straight line. But due to this interface, due to the change in the medium density, optical density, that's why now when it is traveling from rarer to denser medium, here because of the high optical density, the light will bend towards the normal after refraction, and this ray after refraction is called as the refracted ray. Clear? This ray is called as the refracted ray, and the angle of refracted ray with respect to the normal is called as angle of refraction. So as you can see here, this is the angle of deviation by which it is deviated from the original path of the ray of light. So now here we can see that when it's traveling from the rarer to denser medium, always the ray of light bend towards the normal, and the angle of refraction is less than angle of incidence. This is the one of the case. So if you're taking the opposite case of it, then what we'll get, if this is the interface which is dividing the two medium, and this is the normal to the surface like the previous one, and now this is the denser medium, first medium is the denser medium, and second medium is the rarer medium. Got it? So now if this is the incident ray which is making an angle of incidence with respect to normal, and if there would be no interface, then it should travel like this in a straight line. But now because of this interface, when it is traveling from the denser to rarer medium, that means now in rarer medium, as I said, the optical density is less, so the ray of light can move very easily with a faster speed. So that's why it will move, or it will bend away from the normal. It will move away from the normal. So the angle of refraction will be more. So angle of refraction is, that is the angle made by the refracted ray with respect to the normal. This is the normal to the interface. So this is the refracted ray. So here you can see there that R is greater than I. Okay, R is greater than I. So like this way we can check, if I will be 0, then what we'll get? If I will be 0, means now the ray of light will be normally incidenting on that, then it will normally pass through the interface, because there will be no oblique incidence. So in oblique incidence case, always the refraction case, always the ray of light will bend towards the center, towards the normal, if it is moving from rarer to denser, or away from the normal if it is moving from denser to rarer. All of you understood this? Okay. So from here we clear that when the light travels from the rarer medium, the light speed is very fast, and when it travels in denser medium, the light speed is very slower one. So this change in speed is because of what? Optical density, and we can measure this optical density with the help of a parameter that is called refractive index. So this refractive index is what? So this refractive index measures the index of refraction. So we can represent this as a symbol of mu. Mu, that is pronounced as this mu. So now what is it? So we can define this refractive index as the change in the ratio of the speed of light in vacuum, that is C, to that of the speed of light in any medium. Clear? Or we can write this as speed of light in vacuum to that speed of light in any medium. Okay? So this is known as the absolute refractive index of any medium. Clear? So what is the speed of light in vacuum? I think all of you know this. So C is equal to 3 into 10 to the power 8. Or we can say in air also, that is the same thing. So speed of light in air is also 3 into 10 to the power 8, nearly the same thing as that of vacuum, meter per second. So what is the refractive index? In air medium we can check here. So if you are going to check what is the refractive index of air medium, that means as per the definition, refractive index of the in vacuum to that of refractive index in the medium. So what is the medium here? Air medium. So as we have seen here, the refractive, the speed of the light in vacuum is C, and speed of light in air is also nearly C. So we are getting the refractive index in air medium is 1. So always when you are going to find out the refractive index of any other medium other than air, then always we are taking this air medium as a reference for that. Got it? We have to take the air medium as a reference for that. So now we'll check here, compare here for one medium, that is glass medium, what is the refractive index of glass medium with respect to air medium. So if you're going to compare that, then we'll check by the same method. So we can check, or we can compare the refractive index of second medium with respect to one. Then this is called as refractive index of medium 2 with respect to medium 1. Refractive index of medium 2 with respect to medium 1. Then we can name it as mu 2 1. So how we can find? That is the ratio of the refractive index of second medium to that of the refractive index of first medium, mu 2 by mu 1. Okay? So as we know that for any medium, refractive index is equal to C by the speed of the light in that medium V2. Similarly, mu 1 we can write as C by the speed of light in the medium 1. So what we got here, a generalized formula, that is mu 2 1 is equal to V1 by V2 in terms of speed of light, or in terms of refractive index, that is mu2 by mu1. And if you want to find in terms of wavelength what is the relation or what is the formula for this, then as we know here, V is equal to f lambda, and always in refraction everything changes, speed changes, wavelength changes when it is moving from one medium to other, but the frequency always remains same. So frequency remains constant, that means V is directly proportional to lambda. Okay, so V lambda proportional to lambda means what we'll get, that V1 by V2 will get here lambda by lambda 2. So we can define this refractive index of one medium with respect to other in different manner, that is the ratio of the speed of light in first medium to the second medium, or ratio of the refractive index in second medium to first medium, or ratio of the wavelength in first medium to second medium. So you can check here, the refractive index of second medium with respect to one is always directly proportional to the speed, and or inversely, that is a mu. Mu is inversely proportional to the speed, and mu is inversely proportional to lambda. Okay, so from here we can find. So now we check here, we'll compare here what I have said, that what is the refractive index of glass medium with respect to air medium, whether it is rarer or denser, we'll check. Okay, so if you're taking by using the same formula, we'll find then refractive index of glass medium with air, then what we'll get, that is refractive index of glass with respect to air. Then in air medium already I said that what is the value of refractive index, that is 1. So we can say that every refractive index of any medium with respect to air means that is the absolute refractive index of that medium. So mu g with respect to A means that is mu g. We can simply write as mu g. Clear? So and what is its value? We can find. So mu g is equal to mu g by mu A. That means in terms of speed we'll find, then that is VA by VG. VA by VG. Clear? So always in case of air, so if you're going to find what is this value, what is the refractive index of the glass medium, then as we know here, the speed of light in air medium is 3 into 10 to the power 8 second, meter per second, and if it is given the speed of light in glass medium is 2 into 10 to the power 8 meter per second. Okay, then what is the refractive index of the glass medium? So always we are getting the glass medium, the speed of light is this. So that means mu g will be what? If you're putting the formula, then VA by VG, VA by VG. So what's you're getting? 3 into 10 to the power 8 divided by 2 into 10 to the power 8. So we got here that is 3 by 2. That means 1.5. So 1.5 means mu g by mu A. That is only representing the refractive index of glass medium, and which is coming 1.5. Okay. So what you got here from this, that mu g is 1.5 times of mu A. Mu g is 1.5 times of mu A. That means what? The refractive index of glass medium is 1.5 times of refractive index of air medium. In terms of that, we can say that the density, optical density of the glass medium is 1.5 times more than that of the optical density of the air medium. Clear? So what you understood here, that glass medium is 1.5 times denser than the air medium. So here we can say that air medium is a rarer medium and glass medium is a denser medium. So when it travels from, air medium to denser medium, that is, if we take this is the air medium, then this is the glass medium, then how the ray of light will travel after refraction? After refraction it will travel by, that is your what? So after refraction it will travel away from the, as it is moving from rarer to the denser medium. So we can say here this is traveling, if it is incidenting here. Okay. So if it is incidenting here from, this is the rarer medium we got here. So if it is incidenting from rarer to denser, that means it will move towards the center, okay, towards the normal, not center, this is the normal case. So it moves towards the normal. Got it? So this way we can say here, we have concluded here, if you are comparing, then refractive index of glass is 1.5 times of air, and always the ratio of speed of light in vacuum to the speed of light in second medium gives the refractive index of the second medium. Got it? So from this we can solve for any numericals related to this. So if you got this video, very informative, then you can like this and you can share to your friends and relatives or who need this video to check. And also you can subscribe this video to get the next updates. So thank you very much, and please go through these updates, and we'll surely come with a next video. Thank you very much.